below. Now, you're all probably wondering, why is there a picture of a painting here? Yes, you are in a data science talk, don't worry. But I'm going to show you this painting. It's The Ambassadors by Tolman, Deandra. And what's really interesting, I think, about paintings is we often go to art galleries and look at these paintings and, maybe we look at this and go, okay, those are two worlds being, but we don't really understand actually what's happening in the image. But actually, if you understand all the symbolism that's actually in the image, there's an upside down globe, there's a map open to vision, there's a broken, link with a broken string. And all these are symbols that are actually telling you a lot about the painting. So at the time, it was a time of religious upheaval, and a lot of discord happening in politics. So, and that's kind of how I see about image data, that we take images for granted. We just look at the image and we say, oh, that's a nice image, but we don't actually fully value all the data that's actually hidden in the images. So I hope that by the end of this talk, I really get you excited about actually wanting you to go back to your company and say, let's take advantage of this image data. So I will start talking to you a bit about my journey into computer vision. So all of that started during my PhD at the University of Warwick at 2014. And then I'll also talk about how I'm using computer vision today in my role as head of data science at Zoopla. So let's start out with my PhD. So with PhD, we're looking at the connection between beautiful places and our well-being. And when we go to a really beautiful place, like here, for me, come to one end, it was so nice to be here in Maldives, it's so beautiful. And you just get this automatic feeling of this this is so relaxing. And I want to see if I can actually quantify this feeling that's actually intuitive and actually build large-scale data. Because if I can build this large-scale data showing that there's a connection, then, we could influence, public policy, for example. So that was what the PhD was about. But how on earth do you actually go and measure the beauty of a place? But that is not necessarily the easiest thing to do. So normally, when people do studies on the connection between the environment and well-being, they tend to use data that's more easy to measure. So you'll have data on green spaces, distance to parks, maybe land cover, measures of biodiversity, but not really, large-scale data on beauty. So what most people usually do is do a local survey of the neighborhood and try to gather local perception of the beauty of their neighborhood. But this is problematic because you can't really do a survey for an entire country because it would be really time-consuming and costly. But luckily, these days, we spend a lot of time on the internet. And the internet itself is such a fantastic resource for actually collecting data. So I was really excited during my PhD when I found this website called Scenic-Or-Not. And this is created by my society using images from geographs. And it's just a game people play, and they just rate these images between 1 and 10. And it's surprisingly addictive. People started giving you to look a lot of ratings, which is really great. And by the time I got a hold of the data, I had 217,000 images that have been rated 1.5 million times. So pretty nice, solid data set to work with. And if we map out these images, it's even well, a lot of the places that are coming out as being scenic are places, people go on holidays, they go on hikes. It's coastal areas, it's really kind of tying in with our intuition. But there is purposefully the black screen. I want everybody just to close your eyes for a few seconds and just imagine what a beautiful place looks like, and just conjure up a beautiful place in your imagination. So what most of you probably conjured up is probably a scene that is natural. So we'll have lush greenery, we might have beautiful water scenes. Here's a beautiful lake with a mountain setting. And we normally think of beauty as being natural. That's kind of what we dissociate. But the problem is with my PhD, if that's all I came up with, that natural environments that went to well-being, I wouldn't have discovered anything new. Because we already have tons of research that shows that there is a link between natural environment and increased well-being. So I really wanted to understand if we could actually find a definition for beauty that actually goes beyond what natural is beautiful. And so, yeah, and a collective understanding of beauty, right? So if we think beauty is the subjective, and I'm really trying to get to some kind of underlying pattern. So one of the things we can look at with the look of theory, so some people say that we've evolved by different types of environments beautiful because it helped with our evolution. So one of these theories is Wilson's poiophilia hypothesis, and it's talking about how we have an innate connection to nature, and we've evolved to find things attractive, such as, that have aided us survival, such as fruit-bearing trees or primal trees. So, but that's still kind of connected to natural beauty. Another really interesting theory is John Appleton's prospect and refuge theory. And this one is quite intuitive. So, when you go to a beautiful place, one of the things you'll notice is you can look out into the faraway horizon. And it's actually looking far away or see your prospects that kind of makes it feel safe. And you also think it's beautiful. So that could be a connection there. J. Appleton also says that we have to find places that we can find refuge, the kind of cozy places. And so again, just about like being able to easily hide or spot potential dangers. But what does the data tell us? So we've got at least 217,000 images. We did 1.5 billion times. So I wanted to understand, can I get a collective uncover of beauty, but actually analyzing the data? Of course, I can't do this by hands. Really, why neural networks come to the rescue, and they're fantastic algorithms for computer vision. So, luckily, there were this team of scientists at MIT, and they were actually looking at scene attributes and places. So, because one of the things I didn't want is to use your standard object recognition algorithm. So, I don't really care if there's a tree in there or there's a lake in there. That's not gonna. That might tell me something about beauty, but I really need a broader understanding of all the characteristics of the sea. And they were recently doing work where they were actually looking at about 2 million images around over 20 countries. And they were trying to see if they can extract scene attributes to understand the characteristics of various cities around the world. And what they ended up doing is after creating a convolutional neural network that can actually, help extract lots of different features from images. So, you have these 2 images here, and it can extract that there's a probability of a skyscraper in there, or an ocean or boardwalk, but also other things like, is it man-made, is it natural, is it cloudy, is it an open area, can you see to the faraway horizon? So it's such an interesting algorithm that I could use to apply to my images and extract data. So, what did that apply? One more state, this is how it looks like when I actually put the images through the algorithm. So we have a few examples. There's the valley, grass, and meadow variety. And we see from the left to the right, it goes from low probability there's a valley to high probability there's a valley. Low probability there's no horizon to high probability there's no horizon. So that's kind of how it would look. And then, now the results. So, it's intuitive with the natural scenery. Of course, we find settings that are natural, like coastal scenes, valleys and mountains, and forests and trees as being beautiful. But surprisingly, we also see really interesting things. So this is England. We have a bunch of characteristical, beautiful buildings, like cottages and lighthouses. And you also see viaducts and bridge-like structures. We often find bridges really beautiful. And then when we look at what's on scenic, not surprisingly, of course, we see industrial scenes and the highways as being not so scenic. But very interesting, we get the no horizon. So that is, in line with J. Appleton's theory about, when you look into the faraway horizon, you're finding the scene beautiful. But if you can, it was a cost of a resetting. You're also finding the whole scene to be not so beautiful. But a surprising element is people actually didn't rate snap areas and grass as being beautiful. So this is pretty interesting, because just because it's green doesn't mean it's beautiful. This tells us a lot about what we should think about when it comes to public policy. So in England, we talked a lot about green space, the importance of green spaces, but nobody really talks about the quality of that green space. Now, sometimes in low-income areas, they'll just put a bunch of flat grass and go, hey, people hang out here. And that's not actually really engaging for people to spend time in. So this was a really, I thought, an interesting bite. So, going back to the data, I got one image per square kilometer, and remember that I was trying to look at the connection between beautiful places and our well-being. Now, this is problematic for a city because in a square kilometer, there's a lot going on, and one image is not going to be representative of actually the beauty of that square kilometer. So I had to find another way to actually generate data. So I wanted to see if I could actually create my own convolutional neural network to help predict the beauty of new images of the environment it would look at. But I only have 217,000 images. That is not good enough to train a neural network from scratch. So I use a technique called transfer learning, which we use all the time. At this time, I actually again transfer learn on top of the places convolutional neural network. That was the one I showed earlier that does a very good job of detecting scenes. And I trained on top, giving it like over 100,000 images until it got to understand how beautiful the scene is. Now, practically speaking, you can actually use ImageNet or any kind of object recognition algorithm and transfer on that across various different applications, and it'll still come up with a good job. And that's what I discovered later. So, something like Places is not as easy to access these days because it was released a while back. It was like a cafe model. People weren't even using cafe back then anymore. But again, there's like out-of-the-box models that you can find in like PyTorch, TensorFlow, and you could transfer on any of those and actually get really decent results precast for a wide variety of applications. So anyway, the Falcon algorithm, it's working really well, and I wanted to see it actually a force of my own intuition. And I gave it the 200,000 images of a circle geograph all over London to see, is it going to tell me where the beautiful places are around the city? So Hampstead Heath is not too far from where I live. Was a lifesaver during lockdown because it was such a beautiful place to skate to. And my non-but imageries. So whatever's really colorful is green and purple. Is actually the scenic image. That is where it has scenic. Gray is not scenic. And all around Hampstead Heath, it's basically decided that this is a beautiful area. And here's an example of an image that is actually predicted as being beautiful. And central London, there's pockets of beauty that it's down. And if you look at it carefully, there's also a little path. And I was wondering, what's that path? Like, what is that road that's actually pretty? This is really strange. And turns out it's Regent's Canal. So there's a really beautiful canal walk, and it's actually very beautiful. And of course, it's picked up the parks as being beautiful because that's just given. And it's also very smart. It also knows that flat areas of grass, so grass tends to highway network is not that beautiful. So it really did a good job. And finally, it also recognized that the fields up here is so beautiful. And like I said, it's picking up on these characterful buildings that are very characteristic in England. And it's rating it as beautiful. And nowadays, we think we're probably not that surprised by it. But, this was 2017, I believe, when I did this research. And I was like, wow, I can't believe how amazing convolutional neural networks are, how varied they are, which are actually coming up with their prediction. And it was actually mind-blowing at the time. So here's an example. This is how the top beautiful pictures of London. I wish all of London is as beautiful as Malaga, but this is what the beautiful side of London actually looks like. Okay, so we're predicting beautiful images of this example of geograph, like I showed before. But you'll see that it's kind of sparse. There's certain areas where I just really don't have that much data. And that's because people are submitting these images of geograph of things they want to take images of. So that's a bit of a problem because I've got biases in my data that I need to be really careful of. So I then gave in Google 3D images because that would give me better coverage. But if you take a neural network and you apply it on a different type of image, you're not going to get good results. So initially it was really low accuracy. And that's because the kind of image that's actually in geograph is very different from the kind of image that's in Google Street View. So Google Street View is kind of combining different images together, and there's blurry edges, and it's a bit stretched out, and that's problematic for a convolutional neural network because it's really sensitive the type of image. But an easy way to get around it is to collect more ratings. But we actually didn't have to collect that more. I think we collected about like 5,000. And then I again did the task wording up over the neural network, and they did a really great job. And I finally now have a really well coverage map of all the places that are beautiful in London. So it was very easy to adopt. And the other fantastic thing about working with Google's 3D images is that you can look at beauty changing over time. So here's an area in London, it's King's Cross, and it's become more beautiful over time. But it's slightly problematic, so it works really well because with Google's 3D, and you can see that in the left side, there's actual changes. So, actually was for the building that was not down to Greater Park to actually really verify it, and that was actually true. You see refurbishments and places becoming more beautiful because of that. But the problem is, because you only have that one image, sometimes have a problem where if it's a box in the front of that green space, it's going to be rated as not beautiful by my algorithm because it doesn't understand. And if it's construction, it's going to rate it as down as the not so beautiful. If the weather was a nice update, it's going to be rated as not so beautiful. So there's a bit of work that still needs to be done, so actually I'll be able to use it over time. So that's still work in progress. Anyway, I thought that was really fantastic because we think beauty is in the eye of the viewer beholder, and turns out that computer can be trained to recognize beauty as well. So let's talk a little bit about my role in Zoopla, so using computer vision in a business context. So I'm also I'm the founder of BetaPlace.ai. I'm also head of data science at Zoopla. So at Zoopla, we use data science to help create algorithms that help users find how to buy, sell, and rent properties. So we want to create and make more engaging experience for consumers. I also, my data scientism contract was another side with Zoopla. And at Contract, we create automated valuation models that most major lenders in the UK will use to get property valuations. So those are two of the different modes I do. So here is a Zoopla website. Another things you can do is you can look up your home, and you can ask it, like, tell me how much is my home valuable, and I'll give you an estimated price. And then it's connected. So here there's an estimated price, and that's connected to the home top model that I mentioned before. And the way the home check valuation model works is a comparable space model. So we use comparables a lot with these type of algorithms because banks like the explainability is really important. And if you could say we compare to these different properties, it helps them feel more confident in the model. And it's just standard. And a lot of the data that is taken into account, the previous sold price of the property, when was it sold, any changes in the market in general, and then characteristics of the property, how many bedrooms, the things like that. But this is all kind of very like metadata, right? Just about the property. And one of the problems about that is that you can't actually look inside the property like a surveyor would, and you can't tell whether somebody's done renovation to the property or if they've actually either moved or changed them. So what's really great about being across Zoopla and HomeTrack is we have access to all the data that agents upload to our website. So we have about 3 million listings every year with an average of 14 images per listing. So that is a huge amount of data we get to work with. So we thought quite well we use these images to understand if a property has changed. Have they done renovations? Have they added the room? And specifically, we wanted to detect for our automatic valuation model if we can detect if a property has been in poor condition. And so what we're doing is we're triangulating, so we're using the computer vision in the images. We're also using an NLP model on a listing description as well as metadata, because the age of the property will tell us something. And the reason we're triangulating is because sometimes the estate agents do lie, and I do for the best properties, pictures of the property, but then the listing description will say something like opportunity for refurbishment, or they'll have something like a hint that tells you, wait a minute, something a little bit up for that property. So triangulating with a few different data is really important. And our label data comes from surveys. So because in the HomeTrack, with our contract with the banks, is they also give us data on surveys done on properties, and we also have data on whether a property has been labeled for condition or not. So again, fantastic data set to work with. And then it's really important that on the properties that you have to go and label each image for a property individually, because even if a property is in poor condition, like one of the images might be poor, one image might be good, and we need to get the model to understand very specifically where it's finding the poor condition. Here's an example of the poor condition images that we set them up. Anyway, we did a really quick POC and just a few thousand images, and it already worked really well. And here's when it works well. So, on the left-hand side is saying that the 52% probability is poor, and on the right-hand side is a 93% probability is poor. So it's like kind of recognizing that the more damage there is, the more the property is in poor condition. The model doesn't record that right yet. So there are some things it's not really picking up on, and there's like, it's just, floors that are not in really great shape, or very small details that's still picking up on that. Right, and then gardenings, of course, if a garden is a bit disheveled, that is struggle with that. But a very easy way to solve it is just by giving them more examples of the things that's actually family home. And that's actually quite an easy thing to do. And the other thing is the dated interior. So this one I did, it obviously picks the one on the left. This one's tricky because it's a dated interior. It looks like it's in good condition. And this word trade-off is like, if the property's dated, there's likely to be poor condition in there. So we kind of have to make a call as well as to whether we use correlations or not. But we also dated the property anyway. And like I said, it's not that difficult to improve the model. So what you normally do is you take the images to scaling it. You'll see that there's low probability that it's going to get warm. You can basically select, so with a lot of the late tools that you have, what you do is you can select the image of installing it and then use an embedding. And some of these tools already have it built in where you're looking at images that are actually similar, and you can use that to feed more examples of this to the neural network, and eventually it'll pick up all the things it's actually not dealing with. And you can do this as an automatic as a pipeline. Another way we can use computer vision is to also unsend consumer preferences. So Airbnb, when you go on there, the first thing you'll notice is all the images of the properties are so beautiful. And they actually noticed that along with prior to location, the photos of the property were really important to help people to get that booking secured. So the images are playing a big part in that conversion. So in Zoopla, what we're also trying to do is understand the images to also get to some consumer preferences and also what's driving leads as well for very specific consumers. Everybody has different preferences. So we want to add a layer of metadata above the data we already have by extracting characteristics from our imagery. So we can do a lot of different things. So we can also do the standard object detection. Is there a fireplace? Are there wooden floors? But we can also do styles as well. Is it more traditional, modern, or you have some people like here at properties, Georgia and Edwardian listed buildings as well, enabling. We don't actually only have to use the images in our website. We can also go back to the street imagery and start to extract characteristics of the neighborhood as well, because that's really important for consumer preferences. And we can also analyze satellite imagery as well. So you can kind of mystic, is it a dense urban area? Is it a more spread out suburban area? And we can basically analyze the data to gather characters with images. And that's something classically that Airbnb also did because they wanted to start getting more data about the neighborhoods and as well as the property, and using all of that to actually understand consumer preferences. And how to get started with computer vision, one see some practical tips. So don't tell any data science place told you this, but you don't have to stop being a data scientist to actually learn how to create computer vision models. I think there's lots of fantastic pieces out there. Fast AI is mainly based on PyTorch, but that's pretty easy to pick up. I know of the people in AI courses. There's one specifically on convolutional neural networks. I think currently it's doing TensorFlow. So it's very easy to pick up how to work with the models. But the few things analysts keep in mind, your labeled data set is going to be critical as to how good your model is going to be. So you can buy tools like Labelbot to Conboard. Actually, Labelbot, you can do about 10,000 images labeling for free. So that's great if you want to just try out a POC. Also, but Label Studio is an open source tool, so you can also use that and then use it and develop your own kind of tool based on that code as well. So you may not have to pay for labeling services, but this is critical. Some more tips. Imbalanced data. So most of the time you will have an imbalanced data set. That is not a problem. There are things you want to use. You can use something called class weighting or oversampling, and that can handle the balanced data set. So you don't have to worry and not to collect exactly the right balance of data. You can also tweak that based on your parameters that you send the model. Again, the course will teach you all these things. And I think the biggest thing to watch out for is data leakage. I see this, junior data scientists do this all the time. And that is that you want to, when you're kind of testing a model, you tend to cheat by accident. So, you're training a model, then you're looking at your test data set, and you're like, oh, that's not working. Okay, I'm gonna fix that here. And then something's working really fantastically on your test data set. But what you've just done is you've leaked information from your test data set back into your training data, and it's gonna give you a false sense of content that your model was doing well. So what you normally do is we wanna keep a train set, a validation set, which you're using to optimize your model parameters, and then you have their completely separate test set that you don't touch. And you use that at the end to see how it might perform in a real world setting, because it's really important to really understand that, especially when you create something for products. And finally, you can actually let the model performance guide your labeling. So like earlier, I was showing you with the poor condition model, we started with around 500 images that we could see what the model is actually failing on, and we can use that to guide even further labeling. And you can use a pipe like all hacks of learning and kind of do that as well. And this is a nice way of kind of cut short the labeling task. So the labeling is actually really time consuming and tedious, and it's handy if you just work on it iteratively. The future of computer vision, I have to mention generative AI because that is such a big thing going on right now. And yeah, so one of the things obviously you could do is you could do a prompt and you just say, tell me what an expensive house in the countryside looks like. And maybe that can inspire these you could do in your property. But that's a bit of a silly example that we have now. This one is a piece of research from a collaborator of mine. It's not my research, it's Stephen Law's research. It's absolutely brilliant. And it's a paper that's about to come out. And it's basically what they're doing is they're attaching a generative AI model to a convolutional neural network, and then you can actually understand if your convolutional neural network is doing the right thing. And this is a bit of a problem, right? Neural networks can give a black box, and you're trying to figure out, is it doing the right thing? This is one of the ways where you can see what's happening. So the model he's using is he predicts the price of a house based on the images of environment. I need to see what is the model adding to the image to make it predict a higher house price. Obviously, in this one, it's more trees as an example, but you can see how we can use that to create more explainable AI. But we can also see how that could work in a features context. So when all this stuff is working really well, this is more in the future. I think it's going to take a year or so for this to start working on a larger scale. We can actually give people advice on how they can actually improve their house. We can say your current house is gone down in value, but here's what a generated image of what your house could look like if it's actually more valuable, and we can give advice on property renovations people can do. So that's where I see the future of computer vision. So I hope I got you really excited about image data, and you're going to go back to your company and say, let's actually exploit the really fantastic and rich data to fit in our images, because the possibilities are endless. So thank you so much, and let's start.